right? So recording. Now I need to go to share the screen. We're going to go to this one. I'm just picking them kind of at random, but this might be a fun one. Number 3, a classification model for movie recommendations, such as Netflix. Now, keep in mind, Netflix may have very advanced algorithms for doing what it does, right? So I'm not saying that I'm giving you what Netflix does. I'm just saying for that problem, how would you even start to think about it, okay? And then it might turn out that they have some very specific algorithm of how they do things. Got it? Make sense? All right, so, but let's do this one, a recommendation system for Netflix. Okay, so we're going to do the same idea. And then, go back. So what we want to do is we want to know what is the X matrix, what is the Y vector, what are the samples, what are the classes, define a set of features, define the dimensions of X and Y, and indicate what they mean. All right, so I'll probably create a new. Okay. All right, so how do we get, so we know so just so that we remember, we want X and Y. We know this is Netflix and it's recommendations. So what's on Netflix? Movies, right? So there's some kind of video going on there. All right. So what are we trying to predict? We're trying to make recommendations, right? Uh-huh. Right. So like I said, it can get very complicated. So we're going to keep it simple, right? Just for now. But yeah, go ahead. Mm-hmm. Yeah. So right. So what may happen with what actually happens with Netflix, right, is that there's several sources of data, and through several techniques, they create the X and the Y that allows them to actually recommend. But for now, that's a complicated algorithm, right? So I don't want to get into that specifically. Instead, let's just think of a very simple scenario, because the exercise here is how do we get X and Y, for instance? And really almost what is a feature, what is a sample, what is this and that, okay? So what are things we know for sure? We're trying to predict something, right? A recommendation of some kind. Now, of what? Given, right. Well, yeah, but you're talking about getting the data, right? And then using that data. But let's just think, let's define what's a sample and what we're trying to predict. Let's start there. What's a sample and what are we trying to predict? Genre. So genre is something we can use for later, but let's just think, what's a sample? Like what's a movie? Just movie. All right, so let's say, what's a good movie? Give me a name of a movie. Huh? What's a movie that you like? Fast and Furious 13, right? Or whatever number they're on right now. Huh? Or Forrest Gump. Let's go with Fast and the Furious, right? So that's a movie. All right. So that movie appears on Netflix to a user. You're watching and they put Fast and Furious. What do they want? What does Netflix want? They want you to watch that movie, right? If they show you Forrest Gump and you wanted to obviously watch Fast and Furious, you're probably not going to watch that, right? You see that? Okay, so at least we know sample is probably a movie, right? Let's start there. Again, there's a lot of ways that we could do this. This is just one example. So we're going to say that sample is a movie. Now, does it make sense to take every frame, there's 28 frames per second or something like that, of a movie that lasts 2 hours, spaghettify all that and create a vector. It does not, right? So then what does that mean? It means that that rules out that the features are the pixels. Do you see what I'm saying? Now, could somebody do that? Maybe. But for us, it doesn't make sense right now. So then we need other data. And this is where all of you were saying things, right? You said genre, you said something about watch history. So what you're suggesting, all of you, is that you don't, like in the previous example, we used the image itself. Here you're suggesting not the image, but like metadata about the movie. You guys understand what I'm saying? Yeah. That's the key thing. So that's called feature engineering, and it means that every feature, every column, we have to define what it is. So we can take the approach of questions, for instance, as a useful way of getting started. Do you see what I'm saying? So how many movies? It's Netflix. 100,000? Okay. So the M is going to be 100,000. So M is 100,000 movies. So that has been defined, right? That's good, right? Made some progress. N here, remember, this is the X. Notice how I approach this. This is the X. This is the Y. See that? Now, this here is what? Right. Yeah, this what is the number of rows in Y? M, right? It's the same as X. And this one, for now, we're just going to say 1. Okay? Now, what are we trying to predict? A recommendation. But here it's a little bit different, right? Because is it recommend, not recommend? Could that work? Maybe. Oh, yeah, go ahead, please. Would it be put? Oh, am I not being consistent? Oh, I'm sorry. See, this is important. Oh, that's good. That's good. So this is N, right? N. So rows is N. Yeah, be consistent. M, N, and this is N. Very good. All right. So what are we trying to predict? We want to recommend, right? So for that movie, and this actually depends on a user as well, in some sense, right? So for you, but just to simplify it, huh? A percentage. So let's do it this way. Let's think of movies, like you said, right? So your idea of genres, right? So we're going to say that for a particular group of people, young people at a university, right? They like Fast and the Furious, right? So if it's Fast and the Furious, let's say that row is a sample, right? Which represents the movie. We don't yet know how we're going to express it, but we've agreed pixels don't make sense. There's too many. However, we've got Fast and the Furious, Forrest Gump. What's another one like Fast and the Furious? Need for Speed. Okay. Yeah, so car movies, right? So these are, actually, let me use color coding here. So the blue ones are like car movies. I just want you to see the contrast. And these red ones are like romance movies. How about that? They're different, right? So what does that mean, right? So that for a particular group of people, right, they're all the same profile. So that's what this classifier is for, because obviously if I make an algorithm for everyone in the world, it's got to be a little bit more complex. But for just a certain group of people, they'll have a tendency to want to watch either the romance movies or the car movies, right? So in that case, what do we do? Let me switch color here. Green. So if you notice, I could say, for instance, 1, 1, 1, 0, 0, 0, 0. It works. I mean, for our simplified case, it's gonna pick up that the blue ones are associated with zeros and the red ones are associated with 1. Do you see what I'm saying? Does that make sense? At the end of the day, what machine learning does is it correlates a specific set of patterns to the label that we're trying to do. It might make more sense that the y is not 0 or 1, but instead it's a value between 0 and 1. That is also a possibility. But that's not going to be a classification. That's going to be a regression. All right, which is actually one thing that we will do in the beginning. Got it? So this is another thing I'm introducing to you right now, is the fact that the output that we're predicting could be, for instance, 0.20 or 0.30. What's useful about this is, if this is 0.20 and this is 0.30, this is probably the one that you should show first, because you're more likely to see that one because it's more about cars or more faster and more furious. You know what I mean? So that's kind of the idea. Do you guys understand? Obviously, Netflix, to really do a good job and really increase its revenue, has to implement an algorithm that's very powerful. It's also a bit more complicated than this. But this at least gives you an idea of how to get started. Got it? Because, yeah, go ahead. Which number? Because if it was rating, so usually there's a 5-star rating, right? Let's say that Netflix just uses a 5-star rating, then it would be like 0.0, 0.20, 0.40, 0.60, 0.80. It's based on annotation. Yes. So once again, just like before, you had to look at an image and say gun, no gun. Now all of you would go into this annotation scheme. You get Fast and the Furious 1, 0.3. Fast and the Furious 3, 0.3. Fast and the Furious 7, 0.6. You know what I mean? And you get Forrest Gump, 0.1 or 0.2, right? Because it's a 5-star rating or 5-point rating. What's another? A romantic movie for that audience that wants to watch, young audience that wants to watch Fast and the Furious, 0. Or an even more, what's like a movie that none of you want to watch because it's so terrible and outdated? Like what's one movie? You don't know? All right, but there might be a movie that most of you don't want to watch. You find boring, you know. Now what's the latest Batman movie? Yeah, so exactly. So something. And so those would get a 0. Do you see what I'm saying? So this is like, we're just thinking of what I want you honestly to do is to provide a logical argument as to why you selected the things that you selected, right? Why you selected N as 100,000 makes sense, 100,000 movies. M we still haven't defined. You've thought about why, whether you do it 0 and 1s or ratings. So which one do you prefer? Do you think would be rating? Okay, so you want to use 0.2, 0.4. Just bear in mind, if you do that, then it's not a classification problem. It's a regression problem, which is not like it's impossible to do. It's just, you know, it's another set. So if you have a toolbox for classifiers, you open the other toolbox for regression algorithms. You can use, so if there's a decision tree for classification, there's a regression tree for regression. If there's a neural network for classification, there's a neural network for regression. You see what I'm saying? So just little differences in the things that you're using. Yeah, go ahead. Huh? You want 11 classes? You could do that, actually. Well, I see what you're saying. So this one would be a 5-class classification is what you're saying. But the thing is, there is information, more information here, because if you only had 5 classes, then class 0.2 and class 0.8, you know, they're just equal. It's not like one is more than the other in a classification problem. But here in the rating system, where we still have 5 things, 0.2 is less than 0.8. There's like meaning in that difference. Like 0.8 is more faster and more furious, you know, whereas 0.2 is less faster and less furious. Do you see what I'm saying? So regression has that additional value of the more you increase, the more important it is, the more likely. Whereas classification, even an 11 class thing, class 10 is not necessarily somehow more important than class 3. They're equal. Got it? So all of this is important, and all of it can be done. It just depends on what you're trying to do. And in this case, we were trying to do a movie recommender. Yeah, movie recommender. Got it? So again, it doesn't matter to me if you say 0 or 1. Really, that's the correct answer because I said classification problems. But you could do this and just specify that you want the ratings. Okay. All right. So we have Y pretty much done. We have the samples. We haven't done M. We decided that we don't want pixels, right? Instead, we want other features. So that's probably based on metadata. So M is not going to be that large. Whereas before we had 7 and 84, it'll take you a long time to think of 784 different characteristics, right, from a movie. So just start with 10. Do 10. Because you're doing this for the homework. So what would these 10 features be? So now you have to, this is called, as I said, feature engineering. And that means that for, again, think of it as a question. So if it's F3, it's column 3, for every movie, you're asking the same question on column 3. See what I'm saying? So what would be, and then you have to find some piece of information in the metadata for all the movies that would give you this. So who can think of something? Like what's a good, huh? Duration of the movie. That's a good one, actually. So duration means every movie has duration, right? It might turn out for whatever reason that all the car movies last 1 hour. It could be. That's right. I mean, that's very good. So every movie here of the 100,000 movies, feature F3, which is column, the third column, let's say, is the question. What's the duration? Notice it's not a binary question. It's not like has duration or not, right? They all have duration. It is how long does it last? 60 minutes. And be consistent, obviously, in the units. So they're all apples to apples. Good. So yeah, I would say even 5 for all of these kinds of problems, you can say 20 features, but just provide about 5. So let's just do like 1 more or 2. So what would be a couple more? That was a good one, duration. I don't know now. I don't know how good it'll be for the model to perform well, but it's a good feature, solid feature. So what would be a better, yeah. And how would we get that from the metadata? Would there be something there?
Maybe there's something like one nominated for
okay. So a binary thing, right? Oh, that's actually a good feature. So let's say that feature 4 is a binary question, was nominated for Emmy or not nominated for Emmy. I think all these car movies are not nominated for Emmy, right? So at least you know that. So a lot of zeros in this column and for the car movies, and then other movies will have a 1. Yeah, good. And that is going to help you to determine that it's a car movie.
Like might be like year.
Oh, what?
Year.
The year, okay. But again, we can pick a lot of features. Make sure you pick ones that you think will help the model detect whether it's a car movie or not a car movie. There you go. So yeah, that could be. But just remember, let's say that that's feature F2, right? And now, so since there's a lot of actors, superstars, right? You can think of 200 columns, which is basically includes Tom Cruise, includes Vin Diesel. So right. So F2 is does Vin Diesel act in this movie. And then the ones, so the blue ones, were those the carbon ones? So then they would have a 1. And the algorithm then would correlate, definitely, because if you notice, the zeros, I guess, were the car movies. So then notice it's a perfect match. 1. So whenever you see a 1 here is what I'm trying to say, you see a 0 over here. Do you see that? That's how machine learning works. It ignores everything else, but if it picks up on something like that, where there's a correlation, boom, you've got it. So F2, Vin Diesel, is probably a good feature. Does this make sense, guys? Any questions? Yeah. So that's kind of that's it. You know, that's this problem. All right. So I think I'll just do 2 for today. And then as I said, I'm going to do more next time we meet, and I will have ready a few problems for you, okay, where you can do this. So I think you get the idea, right, of what I'm looking for. And then, as I said, 2 more problems next time we meet, and then I'll give you between 3 and 5 homework problems. Okay. So let me do stop sharing here. All right. So that